Hello and welcome to the AI Digest. My name is Joaquin Melara and I'm your host. With me today is Ensiyeh Raoufi. I want to be sure that I said your name correctly.
Yeah, that's okay. Ensiyeh Raoufi, yeah, that's it.
Ensi, you are currently in France, is that correct?
Yeah, I'm a PhD student now in Montpellier, France. Yeah,
Southern France. And originally, you
I'm originally from Iran. I passed my bachelor's and master's there, and now I'm here for my second year of my PhD.
Ensi, I'm really happy to have you here. You're such a lovely person. You have beautiful flowers in the background. You have a wonderful blouse, and I love your hair.
Thanks.
So today we're gonna explore your academic journey, particularly with your interest in machine learning and knowledge graphs. Um, Among that is natural language processing and mathematics and a bunch of other topics that we're gonna cover. But what I do want to hear from you is I want to hear about your journey, where you found the interest, the curiosity, the passion for computer science, and some of the things that happened in between where you started and where you are now. I think that will help
Okay.
people that are considering to take the same journey from the perspective of young women. And I think you're a lovely role model for those people.
Thank you. Okay, thanks for having me. Uh, okay. Let's start from the first moment of the light bulbs. I was always interested in mathematics from my childhood. Maybe I always liked to count everything. I always was counting everything, and I didn't know why, but I was much interested in that. After that, in the school, I found my interest in mathematics, and I really got excited when I was solving some problem, and it was again just like lighting bulb in my mind. Uh, and it goes after a while that I was in high school, and there was some competition between these schools, some kind of Olympiad in computer. That it was the moment that I got familiar with programming. So I don't have much resources because we don't have any computer. So I just went and bought some books, and I started learning about uh, I think it was quick basic programming on Microsoft DOS. And then the day before my exam, uh, I had a uncle that it was the only person in the whole family who had a computer, and I went to him and I started programming on the DOS system, and I wrote printed the hello world, and after that I followed the instructions of the book to print the hello world in colors, and then I used colors to print the hello words. And when I printed the colorful thing in those black and white environment, it was like a moment of a light bulb. And it was so interesting, so exciting to me. So I feel much power in the programming. I didn't know that it is not so limited to the colors, but I was feeling the power. The result of the exam doesn't matter, but it was the moment that my interest uh, got um, got a shape.
Out on fire. Okay.
Yeah, and then after that, for my bachelor's, I chose computer science, and I studied computer science, and it was full of computer and mathematics, the things related to programming and to the algorithms and everything, and I really loved that. I like the mathematics because it is the language of the science. Somehow we can use it in any science, in physics, in chemistry, everything else. And it was the study of numbers and the operations on them and equations and how the functions behave, how they change their behavior. And in my bachelor's, I remember that we have a lesson. It was differential equations, and I got um, a crazy interest in solving the equations. I didn't know why, but I was so much interested in solving the equations. And then after knowing their application in machine learning, now I feel that it was not by accident. So after learning a bunch of programming basics like in Pascal and C++ languages, and a bunch of lessons in mathematics, algebra, and other things, my bachelor's has been finished. It was 2011, and after that I found out that it was somehow the moment of rebirth of machine learning. It was the moment that the people in the world was working on rebirth, giving a rebirth to deep learning, and everything was going toward working with AI and artificial intelligence and machine learning. Uh, After finishing my bachelor's, I had a gap between my bachelor's and master's because I got married, and as a woman, I liked to have children, and then I gave birth to my twins, and it was a big moment, also one of the big moments in my life, and it totally changed my life, and I couldn't continue my educations for 5 years. And I also understood the many lessons that the lessons that I studied in the university are not the most difficult in the world, but growing up some children is much more difficult in some cases. And there are some entrance exams to the universities, and I tried it. I think every year after having babies, and I got fail every time. And after 5 years, I studied a bit before the exam with the collaboration of my husband to keep the children. And then I could be successful in uh, uh, entrance to the university. I started my master's at Sharif University, and in the computer science again because I really loved it. And then at the university, there was some inspirations for me. I was studying in the university that Maria Mirzakhani, the first woman medalist of fields the first fields medalist, the first woman who won the Fields Medal was studied there. And every time that I went, I was going to the
Uh,
library. I was thinking that it's the place that she studied here, and I
what,
should be sorry.
sorry, I'm just a quick curiosity. What is the Phil's medal?
It's an important medal in mathematics. And before Maryam Mirzakhani, I think, if I'm right, 49 men won this medal. And Maryam Mirzakhani was the first woman to win that medal. Yeah. And then I was studying in the mathematic department because for the computer science and mathematics, the department was the same, and the main focus of the department was on mathematics. So I didn't have much choices to go toward the applications of the mathematics. That was the thing that I really was excited about. I really loved mathematics and love mathematics, but I'm much more interested in its application in the real world. So I was looking for finding field of a topic for my thesis that is much more that has much more application in the real world, in the mathematic department, that is not so much easy. And then I found the graphs. And what are the graphs in mathematics? Graphs are some collection of nodes and edges that we can model some real world things with that, some real world, especially networks with that. But why for example, as an example of a graph, if we all know the social networks, we all are a part of some social networks in with our cell phones, using our cell phones. And for example, using the graphs, we can model these networks. Each person could be a node of this network, and they could be connected with some edges. If, for example, if they are friends, and it's a modeling of the social networks using graphs. But
Quick question.
yeah, yeah.
I just want to ask a very fundamental question.
Mhm.
What is mathematics?
Okay. The mathematics is a language of science that it has it has a very wide range of applications, but it is a study of numbers and their operations on them. It is studying the equations and the relation between the variables. It is representing the geometry, and uh, as a whole thing. I can say that everything is mathematics is somehow a contract between the scientists to how to model the world, how to model everything that we can observe. And what are the models, and why should we care about a model? The model, we can say that it is a simplified representation or abstraction of a system, process, or concept. But why should we care about that? Because by a model, we are ignoring the details of each problem, each system that we have, and we would construct a general model, and we are defining some rules, some theories, some axioms, and we are defining some solutions to some problems on this general model. And after that, we can use this model that we have solutions for many problems on this generic model for many real world problems that we have. So we should care about the models, and they are important. And using the mathematics on the models, we can solve many problems. Yeah,
So
please.
you started out counting things. You started out evolving your love for mathematics naturally. You looked at algebra, geometry, trigonometry. You graduated through the steps, through the apprenticeship of the mathematical mind. You got in touch with with the computer class that you had in high school, and as part of the Olympic program, the competitive computational competition that they had. Um, you discovered the power of programming with Hello World and Rainbow Hello World and uh, Hello World Plus Plus. You moved on to learn languages through your thirst for knowledge. You bought books. You sought to make a difference for yourself and find a way on how to apply your creativity to this new medium. Um, you pursued your bachelor's in computer science to further refine that. You got married. You got your unofficial graduate degree rather than machine learning and baby learning or human learning or how whatever tag you want to give that. And then you did your you entered into your graduate degree where you continue to pursue computer science, but as an application of mathematics,
Mhm,
because it's been an area of interest to you.
mhm,
And now we're here. Now we're looking at how to take differential equations, take the advanced mathematics that you learn, and how to apply it to the real world. I think you're saying some really interesting things. Mathematics is the language of science, and how
yeah,
it can be used to model and rationalize the mechanics, the physics of the world. Uh, but mathematics is the pure component, the abstract thinking. Physics is
mhm,
the application of mathematics,
mhm,
and physics is the underpinnings of how we view or rationalize every phenomenon in this in the world, right? In existence or otherwise. So
yeah,
very very
yeah,
powerful.
yeah. Thank you. Yeah, you have another question?
No, I just wanted to recap for my own purposes to stick to
Yeah, you
the
recap very well. Yeah, thank you. Yeah, and when I was studying my master's, there was some course of machine learning in my department. That is, it was not obligatory, but I really was interested in that, and I attended the class, and it was another big moment for me because I got familiar with the machine learning and the project that have been done by the researchers in this field. And it was interesting to me because with so much simple instructions, somehow simple instructions, and just repeating some steps, you could get some high quality predictions from your model. You know, before that, in my bachelor's, I worked a lot on the algorithms, and you should write every step of the algorithms so much in details, and you should trace your algorithm. I did it several times on the paper, and the one of the things that I wanted to say was that during my bachelor I was working with C, C++, and these programming languages, and debugging the programs was so much hard, and it was many times that I did debugging and tracing the program on the paper to find the error of the program. and it was not so much nice and cute as Python. That it is somehow writing. Okay, what is the problem with your with your program? But it was not so much easy at our time, and it was also a reason that I got interested in Python and machine learning.
Uh,
Uh, yeah,
I just want to say I have a lot of respect for you. You were really in a very difficult situation, and I think you made very light of it by saying it was not cute Python. It was
yeah,
a hellish landscape of bits and ones and zeros, showing that there's some sort of malfunction in the compiler, and you don't know where the hell it's coming from, and there's no Stack Overflow. You figure it out, or you figure it out. There's no maybe you asked a colleague, but you were on your
yeah.
own a lot, right?
Yeah, exactly. But the good point was that I really learned what is the language of a machine. Okay, I can here give an explanation of what is a program and what is a programming language. A program is some instructions that you give to the computer to execute some special task. Uh, via some programming language. And what is a programming language? It is a bunch of syntaxes and semantics and um, special commands that has been defined to communicate with the hardware of the computer. And for example, when you write print in Python, the system has no idea about what to do if it has not been defined before for the hardware. So the programming languages are doing that, and it is different for each programming language. As I mentioned, for C, for example, for C language, it is so much different with the Python. And the Python is much more user friendly than the previous languages.
I just want to add to that for people who may not necessarily have a computer science background. As NC is saying, a programming language is a way that you communicate with the computer's hardware, and computer hardware communicates via open, close, open, close. There's these binary switches that
Yeah,
are considered the machine code. Um, but then for you to talk to a computer, there are levels of abstraction, levels where you can talk high or talk low, closer to the machine's hardware. And the initial languages that NZ was mentioning, so C, C++, those types of languages are far closer to the machine and more gibberish, more machine related than human related talk. When you get to cute languages that are high level abstractions, they tell you, "Oh, it's not defined. Oh, please look over here. Oh, you
yeah,
could try again." The other
yeah,
languages have levels of processing time, and they make it very difficult for you to figure out where you may have missed a punctuation mark or uh, not defined
exactly.
properly the type of a variable. So NC is hardcore. NC is a veteran of computer science. Just to give a perspective.
Yeah, and to give an explanation to some much more basic concept of hardware and software. Hardware are the pieces of the system that you can touch it. For example, the monitor, the keyboard, all the things that you can see and touch it. And but for the softwares, it is a set of instructions or the programs that that communicate with the hardware. And there are different softwares. Some of them are application softwares, like all we know, for example, all of the games and the applications that we use, or for example, Microsoft Office Word and all of the things like that. But there are also some system softwares like device drivers or operating systems that are communicating and controlling the hardware in a different way. So I just wanted to add this concept here. Okay, I was
Um,
talking about, yeah.
I, I'm just gonna jump in a little bit there because I read
No,
an
that's okay.
article a
Yeah,
little
that's
while
okay.
back. You illustrated a clear definition. Hardware is hard; it's physical. Software should be soft because it is instructions. It should be modular. It should be dynamic. It should be adaptable.
Yeah.
And one key thing that people don't fully appreciate or understand when they begin in their journey in programming and software is that the programs that they create are brittle and they're bolt on and just layers on top of layers on top of layers. True, elegant computer programming is lightweight and reusable and extendable and handles all use cases, robust, but it's also allows you to keep the human in the system and allow the human power to help the system grow and evolve over time.
Mm,
So
yeah.
I wanted to add that bit.
Yeah, that's it. Thanks for the point. Uh, and yeah, I was talking about going to the course of machine learning and the moment of the light bulb of the machine learning. How magic is it? How simple are the steps? But how magic are? How wonderful are the results? So I started to going to the workshops and to follow some online courses on machine learning. And because I was in the department of mathematics, no one was optimist that it works, and they all said that no, it would be a short period in the history that people are working on machine learning, and the result wouldn't be fine, and it wouldn't work in the best way. But now we can see, for example, the chat GPT-4 that are working like wonderful. They are kind of understanding what we say. It is not no need to debug the programs or the papers anymore, and they can debug it for you. They can talk in your language, and that's the magic of them. So I started my online courses. I did several courses on machine learning, and every time I understood some new concepts about the regression, about classification, clustering algorithms, and the classic machine learning word. And in the classic machine learning world, you should do a bunch of tasks on the data. You should clean the data. You should do the feature engineering. It means that you should extract the features of your input data by yourself. And by the features, I mean the most important properties of the data that you have, and um, you should put it in. You should change the categories to be some numbers, because the models just understand the numbers, and you should do it all by yourself. But after a while, uh, it was deep learning that come into place, and it is using some neural networks in several layers that they can automatically extract the features of your input, and they can predict their result that you want from them. So it became so much easier and much more scalable to use them, because before that it was not so easy to work with the large data. But after growing and developing the deep learning, it became so much more easier. But the problem was that it was not much interpretable, and then the transformers come into place. Yeah.
So we're covering some very dense matter there when we made the switch from machine learning to deep learning,
Mhm.
and neural networks, neural meaning from the function of the brain, the neurons. Can you go a little deeper and just help us define that space? And, I think we went over a high level of machine learning operations, um,
Mhm.
seeking a data set, curating it, cleaning it, organizing it, feeding it as a training, evaluating the model and the output. Can you talk a little bit about that and then discuss how that bleeds into deep learning and then discuss the little nuances between those two?
Yeah. For the classic machine learning algorithms, there were some certain models, certain algorithms for the models that they should follow, and the complexity of the model is defined based on it's the algorithm that it is defined based on. And we should we should cleanse the data. We should, for example, if we have a text data as an input, uh, then you should define, for example, if the task is a part of a speech tagging, like tagging the verb, the nouns, the adverbs in the sentence, then it was not so much easy for the models to do that. You should have some labeled data that has been annotated, has been labeled by some people before, and after having this labeled data, and before having the labeled data, you should remove any, for example, punctuation, any extra things that has been existed in the sentence. And then after a lot of efforts for annotating the data, then you could give it to a model to train it on a part of the data, and ask the model to predict what happens on the other part of the data that you have been separated as the test set. So it was the approach.
So classical machine learning was a set of algorithms, and algorithms is a set of instructions or a way to do things and process particular inputs to create particular outputs. Those held some shape and they required some data shape to be input so that you can have some level of expectation. Initially, you start out by creating a clean training set. So that's sort of the baseline expectations for the model, for the algorithm to understand the context of the data that you're feeding it. But afterwards, as you said, you give it test data and then you give it real data to interpret the validity, the accuracy of how it can predict new information without the tags, without the richness of additional information. What can it add the context from, right? With pattern recognition.
Yeah, exactly. But it is not a magic, because some I saw someone that think that it's a magic. It is not a magic. All the things that happens the inside is kind of mathematical and statistical things. uh, when we are extracting the features of the input data and put it in numbers, and then we would have a bunch of numbers in the space, for example, in 2D space or d-dimensional space, and after having all the points, each of the samples would be a point in our space, and all of the points would shape a crinkled plate, for example, a crinkled space. And then the thing that the model would want to predict is that uh, how the next input, where the next input would be in this space. And for this reason, the model should not be so tight to all the points and just consider the all the points that we have, but it should be flexible to consider some margin, and predict the function that covers the margin for the data that we didn't see before. And the way that the model is doing that is to minimizing a loss function. And what is the loss function? The loss function is the distance between the predicted points by the model, the things that the model never seen before, and the things that we have right now. And here there are some statistical concepts to maximize the likelihood, the expectation of the predictions, and then for the maximizing the likelihood is somehow equals to minimizing this loss function. And to minimizing this loss function, uh, we should we should find the point we should find the point that the function has the minimum value. We didn't see it, but um, we want to find it. We want to somehow predict it based on the expected values. And we are doing that using back propagation, that in each step the model is going toward that minimum point based on the derivative that we have in each point. If you imagine, for example, if we want to find out that where is the wind is coming from, we can put our fingers in our mouth and just take our fingers and see where is the wind coming from. And I think the backpropagation and the derivatives of the function, the partial derivatives of the function, is doing that for us. In each point that we are staying, you can imagine going to hiking and you want to reach out the summit, and you don't know where is it. But at each point that you are staying, if you get the derivative of that point, and if the derivative is positive, and at the next step the derivative is still positive, but it is less than before, then it shows that you are going toward the summit, you are going the right way. It is somehow a sign that you are
Going
reaching. Yeah, you are going up. It's exactly like that. So there is no magic behind that, but all the things are mathematics and statistics.
well, I think you have a very clear perspective, battling C++, battling mathematics, battling everything to do with the machines. So you've drawn, you've sketched, you've outlined, you've mathematically modeled, you've exercised, you've programmed, you've debugged. I think that you have a very clear view behind the curtain of the magic, um, how it works. But I think to people that are working with it with cute Python in a high level interpretation, they input one function and it takes care of lines and
Yeah.
lines and lines of
Yeah.
mathematical hypotheses and formulas and models, and it just abstracts a lot of the work for them. Um, what a world we
Yeah.
live in, huh?
Yeah, it might seem like a magic for them, especially with the pipelines that every day is coming out from, for example, Hugging Face and other platform. Yeah, but all the things behind are statistic and mathematics.
So let's talk about that through the lens of the neural networks, and then let's talk about how that goes into deep learning, and how would you explain the differentiation between machine learning and then the deep learning?
Okay, afterwards, the deep learning come into place. It is the meaning, the definition is so much historical, and it is not new, but it has been used in some practical ways, just like from 2009, something like that. And they designed a network that consists of some. You can imagine how the neurons work in our mind, in our brain. In our brain, there are some neurons that, if they're and they are receiving some information, and if the information that they receive is more than a threshold, then they fire. They fire, and they somehow, or they somehow mm, saying our brain to do something. For example, if the pain is more than some threshold, or for example, if your eye is more than some distance to some object, you should close your eye. So it is the neurons that do that, and the neural networks are based on these concepts. But the information that the neurons will receive in the neural network, in the artificial intelligence neural networks, are some numbers. They receive some numbers, and based on some function that the model will be will train the weights of that function. uh, they finally will predict some results, and the weight that the model is going to update the weights of the update its weights is using again back propagation, and this concept. And also the main thing that here is different is that uh, by coming the deep learning, the need to have the annotated data has been reduced, and they can recognize the patterns that has been existed in the input data, and they can predict the result based on that. On the text data, they are going to mask some words in each sentence, and then during the training, they will predict which word would be at that place, and they are training themselves without having any annotated data. And they will, after some many steps of training, they will be able to, for example, predict the next words. And it was a very big step, very big development in the AI models.
So the difference between machine learning and deep learning is that deep learning has some level of adaptability, and it is able to take maybe semi-labeled or unlabeled data,
Only.
and then
Mm-hmm.
make sense of it over time. It'll take longer, it might take a lot of computational power for it to go through these processes where it starts recognizing patterns, meta patterns,
Mm-hmm.
mechanical structure of whatever it is that you're interpreting, whether it's images, languages, sound,
Mm-hmm. Yeah.
etc., mathematics, statistical patterns, whatever. Interesting.
Yeah,
Okay.
but in deep learning models, the thing that we can define is the complexity of the model. How much the more layers our neural network has, its complexity would be more. So it's us that are defining the complexity of the model. And also for training the models with having the current resources of GPUs and this hardware, very useful hardwares, it is not so much difficult to do that. It costs, but it is possible. So that it's the time that we can see the large language model like GPT that are working like magic.
That's been a source of advancements that before initially when you started with the DOS, it was very limited. Kilobytes, megabytes worth of storage and computational. You
Yeah.
had to be very pure in mathematics to just do functions. But now we can abuse and be lazy and have high level interpretive languages because we can blow computer programs. We have what is it?
Yeah, exactly. I
Gigabytes,
remember. Yeah,
terabytes, quadrubytes.
yeah, exactly. I remember that a big part of our job in my bachelor is was to avoiding overflow, and because we will get soon run out of memory. It was awful.
Yeah, but now you're clean and efficient. Someone
Yeah,
learning today doesn't really care. They're not really
yeah.
concerned about efficiencies or resource constraint. It's about how do I ask 20 questions before I get the right answer from this LLM performing 20 bajillion computational tasks. You were thinking about how do I do everything in the back of a walnut. So
Mm,
very very different philosophies of thought.
mm. Yeah,
So you
it's
you mentioned
wonderful.
pattern recognition with languages. There's that branch of computer science which is natural language processing, and that also
Mm.
incorporates statistics and other forms of pattern recognition. Um, do you want to talk a little bit about that, or would you like to go into knowledge graphs a little bit more?
No, that's okay because I can talk about that because natural language processing is a task, an important task when you are working with knowledge graphs. Because in knowledge graphs, I can give a short definition of knowledge graph and then go to the NLP. In knowledge graphs, we have the graphs, we have nodes which are connected with some edges together based on some relationships, but also each node has some attributes, has some attributes with some values. For example, if our entities are persons, then the attributes would be, for example, their address, and in their address we have a full phrase, full textual phrase. So a big part of our job would be to do the to process the natural language, the language that we speak. And for the natural language processing, uh, about if I want to speak about that, it is enabling the computer to understand and interpret what the human says, and it is exactly what we can see for the ChatGPT model that I think all of us work with. So for the NLP, there are a variety of tasks for that has been done before, and now we can see this succeed in. the large language models. And the task that has been done are, for example, includes, for example, part of a speech tagging that I talked about, like recognizing the noun, verb, adverbs in the sentence, or, for example, named entity recognition, that is identifying and classifying the named entities, for example, the people, the dates, the places in the word, in the phrase, in the sentence that we have. And also the translation is one of the big tasks in natural language processing. And after coming the transformers into place, we saw a lot of improvement in this area. And for the transformers, we can say that their architecture is a bit different from the neural networks, and because the neurons can attend to other neurons, and it was not the thing that happened in the previous models. And they can also attend to their selves, the neurons, I mean. And in the transformers, after having this attention mechanism, the results was awesome, and they improved the translation task much more than before. And after this successful experiment, there were a bunch of models based on transformer, like BERT-based model, and Flanty 5, and other models that has been trained based on them, and we saw a great development in this area.
Uh, so the core component of developing a knowledge graph, as you illustrated in the beginning of the conversation when we were talking about graphs and models and things like that, is that it simulates relationships between entities, right? Some sort of function between entities. And the aspect of natural language processing is that it is a means of knowledge acquisition or building a pipeline for embedding or automatically gathering these concepts, these nodes, and building meaningful relationships between them. I think earlier you made notice that statistically, as you scan through a sentence, you may be able to parse out verbs, nouns, subjects, objects, whatever the grammatical structure of the language is. How do we put it all together, and how do we make full use of it? That's my follow up question to you.
Yeah. For me, at the moment, I'm working on integrating knowledge graphs. And if we want to integrate the knowledge graph, we should recognize the instances that has been aligned in the real world, that are the same in the real world. And if we want to recognize that, we should first analyze their attribute values that are some textual data. That in this step, we should use the natural language processing. And also, for if we want to recognize if two entities in two knowledge graphs are different or not, we should analyze their structure, how they are located in the graphs. And we are using different models, mostly based on neural networks, graph neural networks, to analyze that. So it is the place that I'm using almost all of the things that I've learned. And also, there are some needs to analyze the data and to clean the data, because everything is not perfect in the real world knowledge graphs. There are a bunch of things, corrections that we should do on them. And yeah, and after integrating the data, what that the thing that we would have is a very completed source of knowledge that we can extract very important information from that. You can imagine if for example, the scientists that are working on the medical devices are not maybe they are not so much expert as a doctor that work in just in the medical field. But if you have the knowledge about the devices and knowledge about the medical knowledge, and you can integrate both of them together, then there would be many kind of new information, new knowledge that you will achieve having them.
Ensiyeh, you are a strong woman. You have a rich experience and you have a beautiful mind. And I really appreciate you sharing your expertise with the audience. I want to just make use of the remainder of our interview to talk a little bit about. I have two sisters, and I think that women like you are a strong, positive role model for women that want to go into STEM. Is there anything that you'd like to share in terms of overcoming challenges of life and ardently pursuing your passions, your interests?
Yeah, uh, I just can say that continue your way and don't give up, and you will reach your goal. There are some days that all of us are very tired, very disappointed, and it is so much normal in every person's life. I've read several books about entrepreneurs and the persons that are maybe are so rich, are so successful in their field, and all of them had some days that they didn't want to continue. They've been so much disappointed. They had several problems, but they continued. I don't know this phrase is by who, but there might be. It says that there might be several excuses to not to do something, but just find some reason, just find one strong reason to do that. And it's you that you should decide what to do. I had two children, and it was not so easy growing them up. And in the country that I was living, the situation for the women, maybe it was not equal like in the developed countries. But I continued my way, and I didn't reach my goal yet, but I hope that I could reach it. And I want everyone that wants to enter this field and to be successful in this field, just to continue and just to learn every day, and to work with all of the online resources that we have. There are a bunch of them to learn about the machine learning models, and to do some projects and anything else. Just do that, and never give up.
NC, you started with Arabic, you moved to French, you speak English, you've challenged yourself with many different stages, many different layers in your life. I applaud you. I admire you, and we're gonna have to do some other sort of interview or webinar or segment so that you can further, communicate with the world your mission. And thankfully, with the French academic system, I think it's just 3 years for the PhD
Yeah,
program, right?
yeah, that's it.
So you're more than halfway through already,
Yeah.
and you're almost there. And then someone's gonna be lucky to have you work with them and their team in real world applications. No theory.
Yeah,
real
that's it.
world applications. Um, so thank you very much again for coming on, and yeah.
Thanks again for having me.